So let's define heat and energy. Guys, have you ever wake up on Monday morning and you say, oh God, I don't have energy to go to work today? If yes, can I say working need energy? Can I say energy is the capacity to do work? You don't have energy, you can't work. So if I look at energy and the types of energy, can I say one energy is when you get a chocolate, when you eat a hamburger, that's a form of energy. So it's potential energy, which is in food. Can I say energy stored in a hamburger is potential energy? Energy stored in a chocolate is potential energy. So potential energy is stored energy. If you have a coiled spring, you have stored energy in it. How? By pushing it closer together, by pushing the two ends closer together. Where did the energy came from? From your muscles. So that energy is stored in the spring. Let the spring go. This energy is going to be released. And also, if I talk about kinetic energy, you're driving a car, God forbid, the car hits a tree, it breaks the tree. Can I say the moving car has energy, energy of motion? So, in the case of the spring that we talked about, if you store energy in it and remove your hand, energy is going to be released. The potential energy is converted to kinetic energy, which is producing movements. So can I say that these two forms of energy are interconvertible? You look at the chocolate, it has got potential energy. You eat it, it's going to release this energy and it's going to be stored in your body. And then you use your hand to move an object from one point into another, or throw a ball toward the ceiling. The potential energy of the chocolate is now in your muscles, is going to be released and converted into kinetic energy. So these two forms of energy are convertible into each other. Go guys, let's see if you can do these. Let me know by raising your Zoom hand. Excellent. Good progress. Good job, guys. Do these make sense to you? Do you have any question? Anybody?
I don't have a question. I just absolutely love that you used a peanut butter and jelly sandwich as potential energy.
Do you like that? Peanut butter and jelly?
Protein.
Yes, actually what I do, you know, I'm teaching till 9:15, then I'm on office hour till 11, and 11 I am on teaching until 12:15, and then I go to afternoon for the labs. I'm online to answer questions. So I don't have a time for lunch. So what I do, lots of peanut butter and cheese, mozzarella cheese, warm it for 20 seconds in microwave. Wow, it's delicious. It has protein. It has got lots of good fat, unsaturated fat. It gives you energy. I try to skip the jelly. Why? I don't want a whole lot of carbohydrate because I have gained a lot of weight, guys, during the COVID. So I'm trying to stay away from carbohydrate. Thank you. Thank you for the comment. That was great. And who was that?
It was me. I'm just so used to seeing like, oh, the height of where a roller coaster is after it, hits its peak. It's like, 126 meters off the ground equals potential energy. And that's very different from potential. Like, I didn't even think about that because I'm so used to like physical mathematics of it. But I thought it was really funny.
What's your major, Alicia?
Mechanical engineering, and I'll find.
I can tell. That's amazing. I could tell that thinking about those details is right ingredient to become an engineer. Good job. Okay. So guys, first law of thermodynamics says energy can never be created and it can never be destroyed. Total amount of the energy in universe is the same. So energy can only be converted from one form into another. So guys, can you give me an example of conversion of nuclear energy to solar energy? Anybody? Open your audio. Give me an example of conversion of nuclear energy to solar energy, to light. Where is light coming from?
I guess from the, I don't know what they're called, but the explosions happening inside the sun.
Yes,
Light.
good job. Nuclear reactions in sun, where hydrogen is converted to helium, is producing all the energy which comes as solar energy to Earth and give us life. How about conversion of solar energy or conversion of light to chemical energy? Was chocolate an example of chemical energy? Peanut butter, jelly, chemical energy, where are they coming from? Are they conversion of solar energy to chemical energy stored inside the chemical bonds? You eat them, you are released, stored in your body, going into muscles. How about an example of converting chemical energy to thermal energy? As your engine gets really hot when it's using combustion of gasoline, the gasoline has energy inside the bond of hydrocarbons. And the combustion is going to release the energy to produce thermal energy.
I have a question.
Yes, dear.
Could chemical to thermal energy like be an could sweating be an example of that or no?
Yeah, that's right. Yes, the temperature in our, what is producing the temperature in our body? Something must burn, combustion. That's conversion of food into energy. And
Yeah,
then the energy is stored. Why do we have, yes.
I'm so sorry for interrupting.
No, go ahead, Alicia.
I just took a nutrition class last semester, and what's kind of interesting is there's something called thermal burn after you eat because you're digesting food and there's chemical reactions happening in your stomach or just the breakdown of food. It's actually your stomach is higher temperature because of that. So I think that's a very real example. That's really cool.
Good job, Wendy. No, I know you're Alicia, but Wendy,
Yeah, thank you, Alicia.
use her understanding to come up with an example, which was outside what we thought. Good job. I love that creative thinking and processing information so fast. That means, that gives me pleasure. That means you're in tune with what I'm talking. You process it and you come up, you synthesize new relationship, which I haven't even talked about. Good job, guys. I love teaching to type of students like you in this class. So an example of thermal energy being converted to electrical energy. Well, in an electrical plant, we produce electricity from using coal or from using gas, natural gas. That's an example of conversion of thermal energy into electrical energy. Thermal energy is used to produce steam. The steam is going to turn the turbine. The turbine is moving in an electric field. I'm sorry, the turbine is moving into a variable magnetic field and is producing electricity. How about, would someone like to give me an example of conversion of electrical energy to mechanical energy? Anybody? Just open your audio and give me an example. Electrical energy to mechanical energy.
Battery powered bike.
Yes, electrical car, electrical bikes. How about fan? Right in here in the picture. Converting electrical energy into mechanical energy. So do you see different forms of energy are convertible into each other, but energy can never be created and can never be destroyed? That's the first law of thermodynamics. Excuse me, I have to say goodbye to this woman. Wait. Sorry for the interruption. My wife is going to her practice and she had to say goodbye. Okay. Guys, if I ask you to rub your hands, the two hands together, go ahead, rub your hands, left and right hands, rub it against each other. Do they get hot? Is there heat generated from motions of molecules, motions of hands? Guys, if you have a hot cup of coffee, you place it on your table. Is it going to get colder? Is it going to get cold? Is it releasing energy? So, is it fair to say that heat flows from hotter objects to colder objects? The heat is lost by the cup of coffee when it is getting colder. Where is the heat going? If energy is not destroyed, where is this energy transfer? If a cup of coffee is getting colder, what is getting warmer? Where is the heat going?
The countertop and the air around it.
Air around it and countertop.
It's dissipating.
Countertop. Yes, good job. Good job, Dave. Yes. So the amount of the heat lost by the cup of coffee is going to be equal by amount of the heat gained by air and the surface underneath the coffee. So warmer objects are going to release heat, colder objects are going to absorb heat. So heat always flows from hotter object to colder object. Again, that's what we study in thermodynamics. So how do you measure heat? How do you measure energy? Heat is a form of energy. How do you measure energy inside a Big Mac? What is the unit you use? Is it calories? And just the same way that K means 1000, right? 2K means 2000. So you can express energy in calories or kilocalories. So kilo is 1000 times larger. The prefix kilo simply means 1000 times larger, the same way that 1 kilogram is 1000 grams. So K, kilo means 1000. So the unit for measuring energy is calorie. The international system, SI system, is using joule as the unit of energy. Are these two related together? Yes. Joule is 4.18 times smaller than calorie. 1 calorie is 4.18 times larger than joule. And what is the meaning of K? Prefix K is 1000. So 1 kilojoule is 1000 joule. So these are units of heat. Can anybody guess how much calorie there is in 1 Big Mac? Go, guys. Open your audio. Take a shot at it.
$400,000 or something, because it's you see it says calories on the menu, but it's actually kilocalories.
That's very smart. That's very smart. I'm glad you noticed that. Yes. Anybody else? So it's actually, I think it's 600,000 calorie, which means 600 kilocalorie, which means kilocalorie using capital K. Industry is using capital C. So when then you say 600 capital C calorie, it means 600,000 calorie. And this capital C, this calorie is the type of calorie which you need about, let's say, minimum of 1200. This type of calorie, 1200 kilocalorie, lowercase calorie. I mean, that's for me, minimum. For you guys, you probably, at your age, depending on your age, you may need 2400 calories, 4 Big Macs a day. For me, 2 Big Macs a day would be enough of energy, because I'm not using as much energy as you are. Because my metabolism has gone down as I have aged. Okay. So now I have a question for you. Oh, we already passed 9:15. It's 9:22. I even didn't notice it. Looks like you didn't notice it either. It's so exciting. I'm really enjoying working with you guys. You are amazingly smart and fast learners. Fast learners. Do you have any questions before I stop?